So Kaggle is a website in simple terms. So what Kaggle is, it has a lot of data. So if you are into data science, you can find many competitions as well as a lot of data, large data sets to practice. So you have these competitions as well. If you see the prices, like you have $50,000 for this competition, you can go into the competition and then see the rules, what is expected of you, and then you can participate, and if you won, you can get the prize. So that's the idea of Kaggle competitions. Then you have data sets and hackathons. So the data sets are mainly, if you search about, like, for example, let's say um, data visualization, something, then you can see the topics. Over 9,700 topics are available there. And if you click one of these things, you can go in and check their notebooks. So these notebooks were created like 9 years ago, 5 years ago, 2 years ago, and so and so. So you can look at their notebooks. You can, if you, for example, if you click on this one, it will take you to that notebook, and you can see what they have done, how it's basically a tutorial of what you can do. And then you have the comment section as well, like a social media account. You can read the comments, what they have done, and so and so. Also, they contain data sets. So if you go to their notebooks, you can find the data set. Then you have the data explorer here. Here it is in CSV format, JSON, and then summary files are also available, metadata. If you have an account here, if you have created an account, you can download this. So I have my account, I created this long time back. You can download these things and play with it. So if you like to explore certain topics, it can be about OR problems, it can be about data visualization or machine learning. You can go to Kaggle and find out these data sets and other people's notebooks. There are a lot of such notebooks and tutorials available here in Kaggle. That's one of the key uses of Kaggle. And if you see at the bottom, you have science and technology, computer science, pandas, business, matplotlib, a lot of such tags. Now, since you are interested in business, if I click on business, you can find the find some competition data as well as competition notebooks as well. You can filter from this side. Okay. I hope that is clear, and you can actually play with it. If you have free time, you can go and check. You have data sets, notebooks, and so and so. So it's a great place to practice and at the same time to learn and see how others are actually using data sets and notebooks. The Chicago crime data set, wine quality data set, these are some of the popular data sets. I also have searched here and downloaded them from here. And then you have a lot of trending topics as well. So that's one use of Kaggle. There's another use of Kaggle, that is creating notebooks. Like now you are familiar with, now at least I need a message from your end. Now you know that you have Colab notebooks, right? You have used Google Colab. Yes? Yeah. So you have used Google Colab. Similarly, you can use Kaggle notebooks as well. So how do we create a Kaggle notebook? You can just, if you, so for the first thing is, if I open an incognito and use it, go to kaggle.com. This is the web page that you see, right? Then you can register with Google or register with your email, and then you can sign in. So once you sign in, right? Once you sign in, you will have this account like that. And then you have the competition benchmarks and all these things here to the left-hand side. And once you create this, if you click on create, you have notebooks, data sets, competition, hackathon, benchmark. So we can even, I'm planning to create a little hackathon or a competition for our data visualization class as well, but I'm not sure whether we are going to do it sooner. So what we can do is actually we can upload the data sets and then ask the competition or the participants to use the data set and do their own coding. But today I'm going to explore the notebook. So if I click on the notebook like this, it will open up a similar notebook to Google Colab, pretty much similar, right? You have the notebook and you can change the name here. For example, we can change it to MBN 26, for example, right? So we can rename. And at the same time, you can see now I have created the codes in R. So I have changed the code to R environment. Because of that, you can see there are some example codes being activated for the first cell. How to use R and what sort of codes are useful. Kaggle notebook automatically has shown me that. Okay, but that's there. But of course, you can change the environment. For example, if I go to File, and at the bottom you can see language. See, so File, language. There you can select whether it is Python or R. Now today's class is about R. Because of that, I just chosen R. But if it is Python, you can run Python codes, right? So from our previous classes, if you have your notebook, you can simply, you can simply upload your notebook as well. Import notebook will allow you to upload your notebook that you used in Google Colab. That is also there. And here I have changed it to R. Now, that's one thing to do. And one of the interesting things that I see with Kaggle is that it allows you some GPU. So if you run now, I'll just run it. This is a sample code that it generated automatically. I just run it to show you something. Right. Can you see there is a hard disk, CPU and RAM get activated. So you can see here HDD, CPU and RAM. There are three things. So this is a very useful thing because most of us will have like normal computers, right? We don't have high-end computers at home or even at laboratories in Sri Lanka. So we can actually run deep learning codes and practice deep learning here. It's a very good place to start with. You have in the settings, if you go to settings, you can turn off internet, which means you can turn off the connection. But if you can turn off, I think we can't use the GPU here, but accelerators are available, like GPUs are available. You can see GPU V100, GPU T42. Then you have the environment preferences as well. So it's a very useful place if you want to learn deep learning with a small computer or a laptop. So you don't need to worry about your computer resources until you get familiar with it. You can run your code here. It's a very, very useful feature in my opinion. Because it is not available in for the free version. It's not readily available for Google Colab. Yeah, it may be available, but I like the concept here because you have 30 hours of computing power here in the Kaggle. So it's a very neat thing that as I see. And you can add inputs, right? Upload the data sets. You can see attach a Kaggle data set, model, or competition. So if I add an input, you can search all those data sets that are available. For example, this is one of my data sets, Colombo UHI. This is for deep learning. So there are other data sets as well. You can see Sri Lanka weather data sets, financial statement analysis. You can You can find a lot of data sets from here. So if you click one of these things, it will get attached to your working environment. So if I click on this iris species dataset, it will take you to that web page and you can get an idea about what this dataset is about. As I told you, different people have uploaded their datasets to Kaggle. So this is uploaded by UCI machine learning collaborators. So you have the licensing as well. So you can use this and you can attach this to your working environment at dataset iris species. You click on this, it will be attached to your inputs. Now you can see dataset iris species here. It's very cool. So you can see the iris the CSV and all the other things as well. You can even open the dataset, check for updates or remove it. And if you want to, for example, copy the file path so that you can see it here, right? And you can edit this. So you can see the entire file path here. So if you want to read CSV, for example, uh, you can put this path like that and easily read it from here. So you can see how unique this is. Now, if you have like large scale data sets like gigabytes of data, now, for example, what I do, I use a lot of satellite remote sensing data, which contains like 1 GB, 2 GB per image, for example. So it's very difficult for me to run everything in Google Colab. What we can do is we can run part of the code in Google Colab to download data and then download the data sets that I want as a process data set. Then I upload it to the notebook here. And from here onwards, we can run codes with it. So you can see you can write up to 20 GB to the current directory. So it's a very unique opportunity here for people like me. That's why I share this with you as well. If you run any type of code that you run like R or Python, you can use the Kaggle notebook. So that's what I wanted to share with you. So let's start with our R Studio codes and we'll see some part of it. So let me start with the R dashboard ecosystem. I will first of all, I think I need to talk about the grammar of graphics. I'll start with that. So what is grammar of graphic? Oops, I closed the same file that I want to share. Okay, let's see, it should be here. Let me share this with you first. Um, data visualization. Data visualization. Okay, this one. I will share this link with you. Please check your chat message now. You will find a link. Visualization. Yeah, this one. Share link. So in the chat, you will find a research paper. If you can see it, can you put a thumbs up to my link so you can download it? Okay. So I will open it in my computer here. So we'll just read it together. I know you will not read it, so I'll read it for you, but pay attention to why I share this with you and what is the reason behind this paper. So this one was written by Hadley Wickham. Hadley Wickham is a renowned professor in the area of data analytics, forecasting. If you search about him, you can find like a lot of things about him, like this is Hadley Wickham, statistician, and all those books were written by him. And he's a, if you look at his Google Scholar, you can see the number of citations, and he's a very renowned person in this area. Okay, so the paper is about layered grammar of graphics. Layered grammar of graphics means, now when we think about data visualization, I talked about the philosophy of data visualization in the previous lecture. We talked about how different people perceive visualization, right? In different ways. So the color, the way that you present it, and the ordering, the Gestalt principles like extraneous load, germane load, and intrinsic load, the load of the information that you are sharing with the people. So when we think about visualization as a language, right, we can think of grammar of that language. So what do we deal in a language? We deal with words, we deal with pronouns, nouns, verbs, etc. So if you want to develop a sentence, right? If you want to develop a sentence in a language, we have a certain way of stitching those words, and we call this grammar. That's the simple way of it. So a grammar of graphics is the way that we stitch those graphics, the sentences of our visualization, in a way that it gives us a meaning. So like, for example, if you read this sentence, a grammar of graphics is a tool that enables whatever this is. So you can understand this because you know English language. So you have a grammar in your head. And because of that, you know is used to describe about a grammar of graphics. So likewise, when we think about the visualization, we have a way of organizing graphics. So this is the idea of grammar of graphics. Such grammar allows us to move beyond name graphics, like all these things, and then we'll see what this is. So what is a graphic? How can we succinctly describe a graphic, and how can we create the graphic that we have described? So these are important questions in the area of statistical graphics. So how to build a plot? There is a basic plot. Now, if you look at a table like this, you have an attribute A, B, C, D, a simple data set. And if you want to, with variables named as well, you have a table. So you have to convert it into and the visualization space, right? So even if you have like 1,000, 1,000 as your range, you can't just draw as you wish. You have the space margin of a paper, so you need to make it scaled. So you scale it down, and then you have in a graphic objects produced from the left to right. So you have geometric objects. These are geometric objects. If I show you, so these are geometric objects, and then scales and coordinate systems, and then you have the plot. So when we combine all these things together, we create the sentence of the graphic, right? So then you have a nice chart like that. So that's the idea of creating a graphic. Now, if you go further, where the plots can be complicated. You need to combine different charts like that, or you may have multiple layers of it. So there are components of the layer graphics, and how do we look at each of these things separately? So layers and all. So this paper contains all those information, as you can go through them and get a good idea. I will stop reading the paper from here, but I'll focus on the lecture from here. I will share this grammar of graphics lecture with you now. share the link. Grammar of graphic. So I will put them into the Moodle for sure, but now for the moment you can download it from the chat. So I will start with what is grammar of graphics in R with this slide, the first one. So as I have shown you, the layered grammar of graphics is about structure of the visualization language, including syntax, morphology, and semantics. It is also the fundamental principles of art or science. Visualization, a grammar of graphics is used to describe and create the graphic like ggplot2. So ggplot2 is, if you remember when I showed you the Google Scholar of Hadley Wickham, there was a paper cited. It was about ggplot2. They were the ones who created it. So using that's a layered approach in the in that particular statistical package. So layer has data. By default, you have data in the layer. Then you have the mapping. So these are default things. So when we develop an XY chart, for example, XY chart like we are used to develop, like when we automatically develop something like that, you have data and they are already mapped to XY coordinates. So we cannot think of a visualization without the data and the mapping. So because of that, they are by default available in the layer. That's the foundation. Like we cannot think about about a language without the words and the sentences, right? So likewise, data and mapping are default. Then you have statistical transformation. So what is a statistical transformation? Now, for example, let's say you have data from 1 to 157, for example. Let's say this is your entire data set. So a statistical transformation can be converting this data set 1 to 157 into a normal distribution, for example, so that we can clearly demarcate the boundaries or the central axis. Now, if you want to convert this into a normal distribution, what do? We take the data point minus the average or the X bar, and then we divide by the standard deviation, right? So we can have different ways of this statistical transformation. Also, one way to do another transformation is that where we take the min-max transformation. So what is a min-max transformation? Where we map this 1 to the minimum as 0 and then the maximum to 1. So that is also another way of transforming. So in order to do that, what we do is we take the value minus the minimum and then divide by the maximum minus the minimum. So when you do that, what you get is maximum minus minimum will give you the range of your data. And this one, when X is the minimum, it will be 0 automatically. When X is the maximum, it's the range again, range divided by range, that will be 1. So whatever the value that X belongs to in between these two values will be mapped to 0, 1. So that's another transformation that we do. Okay. So another example of transformations we apply. Then we have statistical objects. Geometric objects. So geometric objects are those shapes, other things that we discussed in our previous lectures. Then you have position adjustments, the way that you align them. Then you have the scale, coordinate system, faceting. Faceting is the way that you organize the chart. Right. Let's look at the layer first. So what is a layer? There are 5 basic parts, as I said. Layers are interconnected and they share common features, like using the same data in multiple layers like a scatter plot overlaid with a smooth regression line. Now here, automatically by our subconscious, we don't necessarily say that there are two charts here, but we automatically understand that there are two charts. This one is a line chart, and this line chart is a fitted regression. So this one was fitted for the data points that you see here, right? So originally in the real world, what we have is these data points. And what we do is we fit this line to that data set. So we have two charts here. One is the data chart, the dot thing, and then the line chart. So that's what I've said. Layers are interconnected. They share common features using the same data, where you have multi overlaid with this. So the same X and Y is applicable to both line chart and the dot chart. So there are two things, but they are overlaid together. They are overlaid, right? Now, let's do this in our R environment. So I will open up a new R. So I will explain to you about this R. I hope you have watched the interactive video, but nevertheless, let me start with a new fresh version of it. So Control L will clean it. So if you open your R, there are few things that you need to know about R. You have the console, terminal, background jobs. If you have run some code, the background jobs will be available, and you can easily scale these things using this icon. So if you click on this one, it will go up and down, see? So you can scale down. Now here also you can minimize or maximize. If you click on minimize, it will minimize that window. If you click on maximize, it will maximize the window size. Right, so here the bottom part is typically the console. Typically means it's the default version of the console. So you can see the console here, and you have R. So if you type in something like 5 plus 4, some mathematics, it will do this, and you can see the answer. So that's the console. And here you can write lengthier scripts, like you can go ahead with the scripting, and then you select them and run the script. So this is the script area. Here at the right end, you can see environment history, connections, and some tutorials already available with R. Whenever you load some data set, you will see it here. The plots, packages, and other things are here. So what we typically do, if you want to create a script, you can go here and start with a new R script. There are Quarto documents. I'll explain what these Quarto presentations are. Then you have R Markdown, Shiny Web App. This is what we will be focusing in our coming lecture. What is a Shiny Web App? Then you have text file, C++, and all the other things that you can do in R, right? So this is the R script area. So I will start with what is available in our handout. So we need to load libraries. So we have tidyverse. So what is tidyverse? Now you are familiar with multiverse, right? Anybody who is watching Marvel or DC movies, you know the multiverse, right? You have Doctor Strange, you have Thanos, you have a lot of people in multiverse. So tidyverse means the tidy package verse. So it's like the universe of tidyverse. You can find all these libraries in the tidyverse package. So if you have not installed it, you cannot load it. But if you have installed it, you can simply load it. So I'm going to load the tidyverse. I can type in the console, but we will be doing scripting, so I will go with the scripting. Control L will clean the console, and I don't want the console at this moment, so I will make it smaller. Right. So now maybe you can't see my typing because the letters are small. So I can change it by going into Profile, Tools, Global Options. Tools, global options, appearance, the font size, editor font size is 12. You can't see the fonts. I will increase it to 16. Say apply and okay. Now you should be able to see that. Let's see global options, appearance 16, console, Lucida. So probably, yeah, I hope that is visible. It should be apply. Okay. Okay. So 16 font size set. Let's start with our library. So when you type in, you can see the package has been loaded, library, and there is something called base in front of that. This means that the library package is available in the base package. So you don't need to install anything else to use this library package. But if the package is not available in the base package, you have to install them separately. So in our case, we have the library package. So what library does is, if you request for an available package, it will load that package into your working environment. Before anything else, I wanted to show you something as well. Before doing anything else, make sure that you set your working directory to the folder that you are working. Now, in my case, it's already set to the teaching folder. But for those who have no idea how to do it, you can get the working directory. That will show you where your working directory is, and then you can set your working directory to the place that you want to be. Now in the Windows, right, if you just copy paste the path like this, right, it has to be within quotations. It will look like that, but when you place enter, it will show there is an unrecognized escape character. That is because the R code will try to find skip through this, and when you escape this one, it doesn't understand this as a file path. So to avoid that, you have to put double escape. So when you have double escape, it will escape the first one, but the second one will make sure that it's the file path. So now you can see it works. So make sure in Windows that you put double escape characters to set your working directory. So when you set your working directory, you can load your data sets from that working directory without setting the path externally because you are in the working directory itself. Right. So we'll start with library. And our library is tidyverse. So I'm going to say tidyverse. Tidyverse. Now, when I say tidy, you can see a lot of packages being activated here. Tidy R, tidy select, tidyverse, right? So I will just press tab for tidyverse. And just to see whether I have it, I will run it. If you have installed it, you will see something like this. And don't worry about these conflicts at this moment. But if you have installed your tidyverse, it will load. Now, I will do the same coding in Kaggle as well to see whether Kaggle has it. So I will load. It's already there. Library tidyverse is there. Loaded. Okay. Anyway, I will just do a fresh run. I will do it in both places so you are familiar with the both. So tidyverse, press enter, and it will load it. And if you want to have a little note on this, loading the tidyverse package, that will be there, and I can push it up. So I have the tidyverse package, right? The next one is creating. I will just go through these Palma Penguins and Nitar libraries without any explanations. You understand what I do right now. So if you don't have Nitar or Palma Penguins, you might need to install them. I will just run them together. Right. There is no package called Palma Penguins. Right. So in that case, what I need to do is I need to install that package. Install packages. and I'm going to give Palmer Penguins package. So this is not a any sort of an analysis package. It's just a dataset package. Palmer Penguins contain some datasets about penguins. So you can see how they get installed, right? Install.packages. Now let's see whether R has it. Sorry, whether Kaggle has it. Let's see. Okay, here Palmer Penguin package is already there. There is no error, right? So in my case, now I have installed the Palmer Penguins. Now I should not have any error. Right, so it's there. Now let's look at the lecture. Here now, the data, we will have to understand what the data set looks like, how it is shown, right? What is the data set that we are working with? So we can do this with, if I type in head here in the console, you can see it's under utilities function. So if I say head, right? Sorry, head, and head x equals penguin. So we have to push through a data set into the head command. So Palmer penguins have a data set called penguins. So if I say x equals now x, since we have loaded this Palmer penguins, the data set also gets loaded. That's the thing. So if I say penguins, you can easily see the package is under Palmer penguins and the data set is penguins. So I'm just select penguins and enter. So it will create what we call a table. It's like a table, but it contains the data type as well. So head means the first 5 or 6 rows of your data set. It contains the species, bill length, flipper length, and all the other things. So you have head x equals penguins. That's the first command. But there is something else as well here. Something like this thing. So what is this? We call this the pipe command. Pipe command is used to make the code readable, and at the same time, it allows you to create a clear workflow. So if I run the same command, head x equals penguins, and then cable means creating a caption, I can run this thing, percentage mark, this thing, and again percentage mark, and then I can run cable caption data set of penguins. So cable. So it's also available in the knitr package. So knitr was loaded here. Cable, and inside that I'm going to give caption equals data set of penguins. Now you can see that table data set of penguins get activated. So how do we, now every time we cannot press the percentage mark, this and this, right? So in order to quickly do that, you can press first of all the shift button on your keyboard, and then the control button on your keyboard, and M button. So if you press this shift control M, it will create this automatically. Shift control M. Okay. So we'll just do the coding again. This one, head of penguins. And with this, you can easily press and enter. Unlike Python, you can just neatly create the coding and press enter to read it easily. So if I run it now, I'm going to close this here, Control L, and clear the console and then run it. You can see the data set of penguins nicely here. So that's how we look at the data set. So we first have to look at the data set, then the mapping. Remember that by default, data and the mapping should be there in the grammar of graphics. So we will look at the mapping. Mapping means what is the relationship between the X and the Y values. It can be XY, it can be any type of data that you are looking at. So penguins, pipe command, select this thing, rename, and you have all these things together. So what does it mean? Now let me show you code one by one. If I type in penguins, this is the data set. You have 334 more rows, so and so. This is the penguins data set. If I want to select the, if I type in select, right, dplyr package, then you have to type in penguins, right? Then flipper length. So what do you need to select? Flipper length in millimeters. So I will just say data and get the penguins here. And this will open up my data set. So if I look at it, so build length, build depth, flipper length, body mass, sex, and the year, species. So this is species, island where they were observed, their bill length and the flipper length and the body mass, sex, and year. These are the data points that we have. So in order to visualize or view the mapping, we need to see their this flipper length and the body mass. We'll have to take one part out of it. So we'll say penguins, take the penguins data set and push it. So pipe command, push it forward and push it to select command. So how does select work? You have to push the data. Now the data is in flipper length in millimeters, flipper length in millimeters. Now you can see that flipper length in millimeters, comma, body mass in grams, body mass in grams in the penguins data set. So we take the data set, use the pipe command to push it into the select command. And when we run it, you can see only those two columns have been selected, flipper length and the body mass, right? So this is part of that pipe command. Next thing what we do is we rename the X and Y. So this is X and this is Y. We rename this to be X, this to be Y. That's what we do in the next part. So we take the entire thing, push it to our next command, and the next command will be renaming X to be the body mass, the flipper length, X to be the flipper length, like this, and Y to be the body mass gram. Now, when we do that, you can see it becomes X and Y because we have set X to be this and Y to be that. That's all. So the longer code makes it easier for us to do it once, but at the same time, it allows us to clearly see what the process is. So penguins goes into select and this thing goes into rename. The entire code runs very smoothly. So that's the beauty of using pipe command. Pipe is available in dplyr, which is available in tidyverse. So that's why you need tidyverse to be loaded first. Okay. Now the statistical transformation part. So we have the mapping X, mapping Y. Then we go to statistical transformation. Statistical transformation is a function that summarizes data by calculating a numerical summary conditional on a variable. It can add new variables to the original data set or create a new one, transforming the data from its raw form into summary or smoothing line. So we have, I shown you penguins. So select island, now you know what it will do. It will take out the island column in the data set, select island, penguin data set, pipe into that, selecting the island column. Then you can say count island, count the island, the number of unique islands will be calculated. So it's very simple. Now, once you start understanding how it works, it's very simple and not a very complicated thing to do. So if you say penguins, select, we know that there is an island column in the data set. So you can select it, or you can just count the number of things in the island. So you can see the unique count will get here. So it's very simple and it's very useful, because unlike in Excel or any other place, you don't need to open the data set and then go through everything. You can script it. By scripting, you make it very easy to use here. Now there are geometric objects, right? Geometric objects are called geoms. So they control the type of plot you create. Geoms are classified by their dimensionality. 0 dimensions means points and the text. 1 dimension means path or line. So if you have a line, that's 1 dimensional. Point is 0 dimensions. 2 dimensions are polygons and intervals. In our previous data visualization lectures, we talked about the complications of 3D visualizations. So we will always stick to 2D visualizations when it comes. Unless or otherwise it is needed, we will not go for 3D visualization. Each geom can only display certain aesthetics or visual attributes of the geom. For example, a point geom has position, color, shape, and size aesthetics. So this is important because I'm just trying to explain how the codes work. So we have ggplot. ggplot is from the tidyverse. So we have ggplot. Data is the penguins. Then you have the mapping, right? XY and the color. So these are aesthetics. If you remember our previous lectures, we talked about data maps aesthetics, right? Scales map data to aesthetics. Remember? So data has penguins. The data is the penguins data set. Mapping happens with the aesthetics. Aesthetics are X, Y, and color. So X, Y flipper, these are positions. X, Y positions. X position, Y position. Body mass value is the Y position. Flipper length is the X position. Then you color it based on the species. So species is a categorical value. So you can define it with colors. And then you have something called plus sign here. This little plus sign indicates that this is part of the geom commands. So geoms. We go with the geom commands like plus. So this is the data set. Then geometry is points plus the GG title. So how does it work? Like in a normal sentence, you think about the data, how you want to show them, and then what type of geometry that you are going to use, and then the title that you are going to give to that data set. So that's how the geometric objects work. So let's look at this, and I'm going to type in here. So let me clear this one. So the first thing is ggplot, right? So you can see ggplot2 is available here in the tidyverse. So we have ggplot, and first thing we have is data. What is the data set? So data is our penguins data set. Now this is not only for penguins, you can do it for any type of data, but we are using penguins because it's easy for us to understand from this data set. So penguins data set is there. The next thing is mapping part. I'm going to map. Sorry, when I'm using the console, I have to be very careful. Data is the penguins. And the next part is mapping. Mapping. So you can see ggplot default mapping. How does the mapping works? Mapping goes as aesthetics. See, aesthetics. And what is our aesthetic? X is the flipper length. X is the flipper length. Mm. And Y is our body mass G. make sure that you are pressing Shift Enter if you are in the console. Y is body mass in gram. Y is body mass in gram. And then the color, I always have this issue with the color spelling because I'm used to British English. This is in American English. So color is equals to species. Right. So if this works, you can see this. Now, what did we do? This is our first layer, right? In the layer, you have data and the mapping. Remember, data and the mapping are default. So in order to create your first thing, you have to have this, like developing a sentence. Like in order to, I'm actually not a very good English. My English knowledge is not good, so I don't remember how the sentences are called. Like you have this noun and something, right? Then something. So you have the ggplot, like data penguins is there, right? That's the data part. And then the mapping has to be there. That will generate this layer. So that's the first layer. You have the X in the flipper length and the Y in your body mass. So these two are there because the mapping is generated. Because if you do not give this mapping here at the very beginning, it cannot identify the length of your X-axis and the length of your Y-axis. That is the reason. So you have to give the length of this and length of this in order to create this object, right? So the name of it, flipper length as your x-axis and the body mass as your y-axis. So you have to do that as well. Color species, obviously, it's not needed at this instance, right? But it gives you the idea that there would be some categorical values as well. So data comes from the penguins. That's the main thing we initialize. Right. From here onwards, the next part is adding something to this. So if you say plus, we are doing it on top of this. So we are overlaying this chart. So what do we overlay it with? Geom point. So geom point means if you say geom, you can see all the geometric things that are available. Geom bar, geom column, and all these things. So we need geom points. Points are the data set, the single or zero dimension data geometries that we need to plot this. So if I just enter this and do it, you can clearly see it has mapped everything because the mapping was there. We said X is flipper length, Y is body mass. If we did not specify the color will not come. But since we have specified the color species, it automatically have done it for us. So you can see flipper length and body mass XY, and then the color in our legend. So you can see the color, and it's very beautiful, with very simple code. So geom point all or overlaid that it actually gave a definition to the visualization, point visualization. So the next thing is the title. Sorry, the title. So what is the title? ggplot. ggplot title. So gg title. We'll just enter and give it gg title. So gg title is going to be, what was the title? A point geometry with position and color aesthetics. Point geometry with position and color aesthetics. Fun. A point geometry with position and color. So once you do that, it's very simple. You can just, if you are happy with what you have done, you can just copy it into your code here. So you can save it. You can save it. And maybe you can name it like um, data nar or something. Save. It will be saved like that. That's all. So what did we do? We talked about the geometric objects part. So the geometric object gave a definition to our data set, right? We created this, we created everything, and then when we put geom point, it gave a definition to our data set. It's like what you call this, I don't remember what adverbs or pronouns or all those things, right? So it's a if you say written, it was written, but you say if it was beautifully written or something, you have some explanation to it, it gives a meaning to that sentence. So likewise, we have this geom point. Then the next one is you have the data. Then here, in the case of aesthetics, we said mapping is for X, Y, and color. But we can also say data is there, aesthetic is for X, just one type of a variable. So island. So the same command, I will just use the same command, but instead of penguins aesthetic X, the value of that, I will go to the code and change that part. So now I don't have all these things in my X. Instead, I have my aesthetic as island. Aesthetic is my island. So I'm going to say aesthetic X is my island. Islands. I don't know. Island or islands. Should be island. Island. So X is island. It's not a geometric point anymore. Let's see what will happen. Okay. Let's see a test. Let's see what will happen. Press enter. Problem while setting geom. Error occurred in the first layer. Geom point requires the following missing aesthetics. So why do you think this didn't work? Can you send me a chat message? Why this code fails? Why do you think this code fails? What I did was I changed the aesthetics to island and I kept the same code. Why do you think this code fails? Any idea? Yes. Got one answer. Any other? Why do you think this code fails? Yeah, correct. So when we talk about positions, right? Points need to have a position geometry, right? The geometry works when you give the coordinates. So we have the geometry point defined, but the point has no definition of y. Because of that, it cannot put the point in the space. That's why it is asking us to set the y. That is the reason why it fails. So you can't do this geom point with one variable, but you can do it with bar charts. So you have island plus now it's a geom bar. Now if I go ahead and change it to instead of geom point, geometry bar, right? It will automatically do the work for us. And what is that work? What is that work? It takes the X as islands, right? And then it summarize it because the count is what you see on your bar chart. We only stated one variable, right? There is a very important thing. We stated only one variable. X is island. Island is there, but we didn't set any y value. But when you put geom bar, it automatically does the summary for us. So it calculates the Bisco Dream or whatever the name of the island, how many time it appears in the data set, and then takes that number and put the bar chart. So that is the difference. When you put geom bar, it automatically calculates that numerical summary for us. So let's go ahead and keep this code in our code script as well. So this is our, it's not it's a bar, a geom bar chart. Right, a bar geometry. Now, what do we have? Now we played with the values, right? We created the bar chart without giving any instruction to it. If we gave instructions, like now in this case, we are telling it ggplot mapping aesthetics x is island, y is the number of it, and the fill color is species, right? So the geom bar also says identity. Identity is important because identity will give us the statistical value, and then the position can have dodge and if you, so these are two charts. One chart is on top of say if you find one island, one type of penguins, the other type of penguins. In the Dodge case, you have this as two separate clustered bar charts. So that's the interesting thing about creating the Dodge chart. So let's go ahead with that and do it. So count is X penguins, right? Control L, and this is the code. Geometry bar, island, same thing. Now, in the data, ggplot, can you see something has changed? We don't go into geometry ggplot mapping directly. We don't plug data like this. Instead of that, we have something in front of it. So data in the ggplot has to be defined first, then go with the mapping. But instead of doing that, we do the separate counting. So count X penguins, species, and island. Count them separately. We count them separately. Count and then pipe it. So then we plug the idea of pipe command is just like water. We pipe it in. So we count the value somewhere else and then pipe it in to ggplot code. When we do that, we don't need to mention the data because ggplot automatically identifies the pipe command prior to that what has happened. So we have counted the number separately. So we will count the number of penguins, species, and island. X equals penguins, species, and island. So we'll count X equals species. Do you have species, island, species, island? Island, species, island. X equals penguins, species, we have to calculate the penguins count as well. Penguins, species, island. So now if I run it, it doesn't show anything because I haven't given any aesthetics to it. But it works, right? The count is now calculated. Now I'm going to say mapping is aesthetics. Now here I have mapping, aesthetic, X is island, Y, because now there's a calculation coming up. Y is the N, fill is based on the species. So Y is equal to N, and species, fill is the species. Fill is the species. Just go ahead with this. Right. So aesthetic is X equals island, fill based on the species. You can see the species count. There is something, yeah, because of the geom bar was not set. We'll go ahead with say stat. is identity. Now you can see the code, right? So n is on your y-axis now, count. So stack bar chart, and you can easily run the second command as well and find out the dodge. So you can do it by yourself. Position adjustment will work like jittered or other things. So we'll look at the scale. So what is a scale? In the case of scale, ggplot, geom_point, and guides can have different colors, right? Guides will have different values. Now here, ggplot, data penguins, the same thing, color species, geom_point. Now instead of the visualization that we did early on, here, ggplot, data penguins, this thing, body mass, color species, geom_point is there, guides are there also. So I'm going to take this command again and show you what will happen if you put guides. Geom_point command, enter, it will give us this thing. But now instead of gg title, we'll keep gg title there. But I'm going to add a new thing, and that is going to be guides. So I'm going to use guides, and the guides will be color equals guide legend override aesthetic. Guide legend. You will see what we do here once you see the visualization. Override aesthetic. So we are overriding the already given aesthetic, and we are changing the list size to 4. That's what we are doing. Basically, we are overriding list size equals 4. So when you do that, you can see the color, this has changed. So previously, the size of the species was small, it's the same. But now in the new code, it changed to a larger size. So this is useful when you are developing visualizations for your research papers, or when you are doing publications. You can change the visualization based on your requirements, and change the, even now here, exists body mass. Now if you are doing a publication ready paper, you can actually you should not put them like that. You can say millimeter very nicely, and then body mass in gram, like this, right? Oh yeah, sorry. It's because the exact X and Y coordinate X thing comes from the name of it, right? We need to change it in different code. So I will skip that part. You can change it. You can search for how to do it, because now what I try to do there was that changing the values here, it doesn't work because the value comes from this. So you have to change it using override of aesthetics, and changing it to is like we did here, overriding the guides, color guide legend override. So likewise, guide axis, override that, and then write this flipper length name like you need. Okay, so that's an additional task, so I will not go into that. Okay, so coordinate system, I'll skip this part as well, you can read it. So coordinate systems have different meanings, and faceting means you have multiple charts stacked together. So you have seen this in research papers. You have like multiple charts together. So you have body mass and the y-axis, and you have the flipper length in the x-axis, all nicely shown together. So you can have a nice insight, a clear insight of This now, when you see this chart, what you can, I'll go through the code again, ggplot. We will put data as penguins and mapping will be aesthetic to the flipper length. Flipper length in millimeters. Y is the body mass. Body mass. And then the geom points. Geom point. Facet trap. That's where we do the facet trap. Facet trap will allow us to create these facets. Facets variable based on the variable. Facets equal variables are species. So that's why vars are species. Based on the species variable, we will have this. You can see it now if we zoom in. Now tell me what insight can you derive from this visualization? You have flipper length on your x-axis, body mass on your y-axis. What do you get? What insight can you derive from this visualization? What do you think? So we created the facets based on the variable species, right? And you see the visualization. What do you get from the visualization? What is your insight? Any thoughts? Any particular idea? The longer the flipper length, the heavier the penguin. Okay, very good. But look at the way that we have clustered them. There's something more to that insight. This is not about flipper length at all. You would see that. What you have identified is when you see your x-axis as a continuous axis, but it's not like that. This is one chart. This is another chart. This is another chart because we have used the variable species to facet it. So these are species. The same chart for different species. Now what do you get when you look at the visualization? Any particular thought? So I repeat, these are different species. Adelie, chinstrap, gento. Let's say species A, species C, species G. So now what do you get? By looking at the visualization, what do you see? Gento penguins tends to have longer flipper. Excellent. That's the idea. So when you look at this chart, clustered according to the species, you can see a particular species, so this Gento species, have a higher body mass and flipper length as compared to this. So these are research paper findings. When you write a research paper, So you do your visualization. So that's how you find visualization in your context. You have visualizations, but just doing fancy visualizations will not actually help you. When you do different visualizations, now this is an additional comment. A lot of students, when they do their research work, come to me and ask like, how do we actually visualize things? As I told you, visualization is a language. So like any language, you need to practice it in order to understand the best way to use it. Now, if you are writing a novel, if you are writing novels or poems, you understand that you have to write many things and many versions of it, right? Then you will find which version is more suitable for your application. So you take your data set and you do multiple visualizations and see what actually gives you the best idea or the best visualization for your narrative. That is the most important thing in when you are doing visualizations, particularly static visualizations for publications or reports, etc. Because now clearly you have a message here. The Gento species they have more body mass and higher flipper length. So that is the message that you want to give, and the visualization clearly shows it. And few more things that you can do with this is that you can create maybe a box plot to this and another box plot to that. And this box plot also will give you the idea that this is not an anomaly. Or also, the species itself has a clear distribution, and this is contained within this region. So another very good insight that if you want to include in your research paper or your report. So that's what I just want to share with you regarding this faceting. So you can do multiple versions of it and see which one is more suitable for your narrative. Okay, so I will. So what did we talk about today? We talked about the scale. We talked about the coordinate system. We talked about the faceting and how we can use R to do a very nice, neat visualization. Okay, so I will end the lecture for today.